Hi guys, it's Tuesday, April 25th. Sorry I didn't have the video working yesterday. Technology was totally not working for me yesterday, but we're back up today. So what you're going to get today is the reported category 2 review packet. So make sure you get one of those. You're also going to need your TEKS document that you went through after you graded your test with the boxes. Grab that from your release star test, and then you'll have your review packet. Reported category 2. Okay, this is your reported category 2 review packet, same as reporting category 1. What I'd like for you to do is take your paper that you used after you graded your release star, that you had the boxes that you've crossed out for the questions that you got wrong, and I want you to underline your strong TEKS and underline your weak TEKS. So from that information, the ones that you got most correct, you're going to underline those. Those are your strengths here, and circle the ones that you need more work on. For the next three, it says determine the net force, the size and the direction for the following three systems, or the following three examples. So the first one, over here, you've got 2 newtons going this way, and you've got 5 newtons going this way. So with the net force, you got to calculate, you got to subtract. So the net force is 3 newtons, and it's going to go this way, and it is unbalanced. The net force on the second one, you've got 2 newtons going this way, 2 newtons here. So if you subtract those, the net force is 0 newtons, and it's balanced. It's not going to move. The third one, you got 5 newtons going this way, 5 newtons going this way. They're both going the same direction, so you're going to add. It's 10 newtons for the net force, and it is unbalanced. It's going to move. It's going to go this way. If the forces acting on a moving object are balanced, what will the object do? The object is going to continue with the same speed and direction, unless something acts upon it. So it's going to keep going the same speed in the same direction. If the forces acting on an object at rest are balanced, what will the object do? So if the object is at rest, it's going to remain at rest. If the forces acting on a moving object are unbalanced, what will the object do? The object is going to move. If the forces acting on an object at rest are unbalanced, what will the object do? The object is going to move. The difference here, if the object is already moving, it's going to either speed up or slow down or change direction. So you're going to have a speed or direction change. Force is measured in what units? Newtons. You'll see a capital N. Friction is a force. How does friction affect the speed of a moving object? Friction is going to oppose motion. So friction is going to make the object slow down. It works in the opposite direction. The last one, a submarine is traveling in the water at 8.5 meters per second. Suddenly, the stomach encounters a swiftly moving current. If the current is flowing against the submarine at 3.0 meters per second, how will the sub be affected? So this one, you're calculating net force. So you take 8.5 minus 3.0. to get your answer. And you get 5.5 newtons. Oops, my bad, not newtons. 5.5 meters per second. So it's going to slow down just a little bit. A diagram of the forces being applied to a box is provided below. If the net force acting on the box is 10 newtons to the right, what is the magnitude of the force applied by the boy pulling on the left? Record your answers. So this is one of the griddable ones that you might see. So to calculate this one, I'll let you guys do this one. What you got to do is you got to add up all of the forces going in this direction to the right, and that's going to leave you with how many newtons are going to be here. So your answer is going to be as if the box had balanced forces on it. So you know how many newtons are going to the right. You know one of the forces that's going to the left. So calculate how many newtons is this guy pulling with right here. Which of the following objects requires the great amount of force to produce the acceleration shown? So what you're going to do here, you know the mass, you know the acceleration. So you're going to use your formula F equals ma. Mass times acceleration, multiply those together, and that'll tell you the greatest amount of force. So I'll let you calculate that out. For each object, you're going to take the mass, multiply it times the acceleration. That tells you the force for that object, A, B, C, or D. Whichever one has the greatest force is your correct answer. The last one on this page, a student applies 2 newtons of force to a toy car, causing it to accelerate at a rate of 10 meters per second. What is the mass of the toy car in kilograms? Record your answer in the grid below and show all your work. So with this one, you're going to use the same formula, but you're going to tweak it a little bit. So use your triangle method. You've got the F is on top, M here, A here. So it tells you how much force, and it tells you the acceleration. So you're looking for the mass. What you're going to do is you're going to cover up the M. That's going to tell you what your new formula is going to be. So you're solving for the mass. So your new formula is going to be F divided by A. So you know the force, you know the acceleration, divide, and that's going to give you your answer. So continue going through there. Stop when you get to the bottom of page 5 on your review. We're going to go through the rest of it tomorrow. So stop when you get to the bottom of page 5. If you need to go back and review some of the questions that you didn't get to for homework from yesterday's packet that I gave you at the end of class, make sure you go and do those. And again, stop at the bottom of page 5 for today.